In this chapter, we're gonna talk about clusters and a couple of other things. Okay, so now I would like to add more complexity to the global effect by setting different size, not for each primitive, but let's say I would like to have, as we've seen on the reference, a kind of soft body effect. So let's do it. And I will do it there. So let's have a bit more room. Oh, and I would like to take this one as well. And this one I want it here. Okay. So in order to make it easier, I want to split the area where the soft body is going to be emitted. So let's say I don't want the inside mesh, so at inside mesh equal 1. Let's set a point like this and see the viewport. Okay, so I don't want that. So let's have a null there. I would like to avoid as well the inside. So let's choose inside and actually invert. Okay, and now I would like to iterate over each different piece. So I want the name, and let's set, for example, for now, a single pass. So this is what I want. Now I'm going to add a glue cluster, like we have done on the disintegration effect 1. I don't want you. Actually, I'm going to allow editing of contents, and I can delete this one, those one, you, this one, and the value that I liked was 0.1. And I would like as well to promote my cluster attribute. So attribute promote here the cluster from point to prim, and let's say the minimum. Okay, so now let's see if it works on the primitive. Yes, it seems so. And let's go back. I would like to show you an example as well here. So let's copy paste it there and dive inside. So let's check the first one, the grid. Okay, with a remesh. This is an attribute wrangler to calculate and attribute the cost attribute, but we are not going to use it for now. Okay, so I will take it off there and use the edge fracture. So this is used for the velum operations, but I was trying a couple of things with that. And for example, here you can add a bit of complexity with the point cost. So my cost here is just a random, and here you can change the size, let's say, even if it's not really the size, but it's quite nice. Even though if you start from something like this, for example, a sphere with a scatter over the surface with a Voronoi fracture, so this is what we have. I'm computing the cost as well, and let's see what we have here. So the way of calculation of the cluster is based on the connectivity. I mean, if you look inside, this is with the poly radius, and this number to keep, for example 1000, is going to be this one. So you could say let's iterate over each different pieces, and this is what I've done there with the name. But again, the result, as you can see here on the edge, it's not exactly what I want. And this is why I've tried with a glue cluster. So here, actually let's go back a bit earlier. Same thing than before with the attribute promote with the maximum or the minimum as you want. I'm just computing over the primitive the I cluster attribute with the random f hash and just visualizing the I cluster here. And if I do the same with a for each over the name with the same option and the same settings, as you can see now, I do have the same, because the way of calculation of the cluster is based on the position. It means if I dive inside and here I'm seeing the Voronoi noise here, it's taking the position. And this is why I do have the same result between both outputs, I mean, because here there is the same function. Okay, so let's go back And I would like to add more variation over each iteration. So let's add create meta import node. And I'm going to link, so let's say the offset detail, let's say -1, because I'm going to add the spare parameter, the spare input, sorry. So I will need the iteration and the first index. Let's copy that and add the spare input there, and I want this one. Oh yeah, right, I cannot do it. So let's make it like this. Okay, and I would like to copy that. Oops. Okay, so now I would like to create an attribute based on the cluster. So as you can see here, I do have a cluster attribute and it's a float. So let's take a look to this one, primitive, and it's like this. So I could use the exact same way that I've used there, the iCluster with the random f hash, but for some reason that I will explain later, I'm going to transform the float into string. So let's add an attribute function, and I want to build over the primitive s at my cluster equal sprint f, like this. I need the modulo g with the f at cluster. So let's see the result. So I do have my cluster with the same value, but if you look at the type, my cluster is a string with 34 different values. So in order to make it more understandable, again, I have done an example. So let's copy paste it and dive inside. So here is the add just with 1 point there at the origin, because this is all what I need. And I wanted to talk about the convert attribute type in Vex. So let's do it. And I'm iterating over the points. So let's see what happens. Okay, so let's focus on the test one. For now, I will take this off. And this is the test one. So the I to A allow me to convert an integer into a string. But if I do 55.5 here, I will have this 55. So it's not going to work. So I should use the f2a, but there is no function f2a. So we are going to use the sprintf, but we will see that later. And I've just added this line to show you that it was a string. So 55, and this is a string. After there is the a to I, so convert a string to an integer. So my string was 1.25 and it becomes 1. Same thing for the test 3, but instead of a to I have a to f with the same value 1.25 and I have 1.25. So now we can talk about the test 4. Let's hide the position, I don't need it. So first of all, let's isolate this one and see with the documentation what is it doing. So it formats a string like printf, but returns the result as a string instead of printing it. And this is what we want. So there is no different option, but we can see them to the printf. So if we go a bit lower, just there, you have a couple of examples with different value for what you want to see. So we want to use the general form. So we are just going to use the modulo g, %g, sorry. But you could, for example, do it in octal. So you just need to set the format, so the general form, and your variable. So in this case, it's p, and it's a string, test4 string. So I can add, for example, the position, so it's a vector. I can add an array, so I'm creating it there and I'm adding it here, and add to all this result another string. So this is what I have: p, position, an array, and a string. And all of this makes one value for my string attribute, test4. And that's it. So it was just a quick review. And let's make it bigger and go back there and say add my cluster attribute. I want to make it red. And I would like to add a bit more complexity over this attribute. So let's import and iteration like this equal, let's copy paste the detail attribute with the semicolon. I want to add the spare input, and it should be the same as this one. I want to convert this attribute, and because it's an integer, I just need to use the I to A. So plus, let's say this plus I to A with my iteration. So let's check the attribute over the primitive. I want nothing except my cluster, and this is what I have. But instead of start from 0, I would like to start from 1. Okay. So let's go back to the viewport. I want to iterate over each piece. And now I would like to check my cluster attribute. So let's add a for each. I want to use my cluster. And with the single pass mode. So let's see what happens. So it works, but this is what I wanted to show you, because the glue cluster is based on the position, so we can have that kind of result at some point. And it might be not a problem, but in our case it will be. So I just would like to modify my cluster attribute in that kind of case. So I'm going to compute the connectivity to have the class attribute over the primitive. So I'm going to add a fuse just in case, like this, with a really small value. And I want to compute the class attribute with the connectivity over the primitive. And actually here I want to take off those, because I want to have the same primitive number. To just copy the connectivity, so from on the primitive, like this, class. So if I take a look to the geometry spreadsheet, I should have 0 and 1. Yes. So now I can modify the my cluster attribute, like this, on the primitive. So let's say s at my cluster plus equal. I would like to add something like this, plus I to A with the I at class, and let's say plus 1 with the semicolon. Let's see the geometry spreadsheet. So now I have added this one plus the class plus 1. So 1, and here it should be 2. Yes, we have 2 because it's not like this. Okay, so this is what we want. And just by security, I'm going to add another metadata that I will link to this one. And I want, let's say, the ant iteration equal detail .u. 1, I want the iteration with the index 0, and I want to add it here. So plus this and plus I to A, and add the iteration. Okay. So it should be the iteration 7. Yes, it is. And let's add plus 1 here. So I want to rename that add class to my cluster. Let's make it red. And compute all the pieces. So now that I'm sure that my cluster is really unique. Okay. And I would like to add the compiled block as well. So let's do it. Compiled block. So here and here. And another one for this one. Okay, so let's make it a bit better. Okay, so this is what I wanted. So now I'm going to merge everything. this, and like this. And let's continue to the next chapter.